Dear all, this is Dilip Udhani. Today I will teach you two topics of vector calculus. One is divergence and the second one is curl. So first of all we will take divergence. What is divergence? The divergence of a vector field f bar is denoted by divergence of f bar or nebula dot f bar. So indirectly we can say that the divergence of given vector field f bar is a dot product of nebula and f bar. That is divergence of f bar equals to nebula dot f bar. Nebula is I cap del by del x plus j cap del by del y plus k cap del by del z dot f bar is f1i plus f2j plus f3k. Now we have to find out dot product of these two vectors. So I dot I is 1, so it will become del f1 by del x. J dot j is 1, so it will become del f2 by del y plus k dot k is 1, so it will become del f3 by del z. You can see that this is a scalar quantity, so divergence f bar is a scalar quantity. If divergence of f bar is 0, then we will say that the given vector field is a solenoidal. Now we will take next topic, that is curl. The curl of a given vector field f bar is denoted by curl f bar or nebula cross f bar. So indirectly we can say that the curl of a given vector field is a cross product of nebula and f bar. So curl f bar equals to nebula cross f bar, and nebula is I cap del by del x plus j cap del by del y plus k cap del by del z cross f bar is f1i plus f2j plus f3k. Now we have to find out cross product of these two vectors, that is determinant of ijk del by del x del by del y del by del z. It means x, y and z component of nebula, and then after x, y and z component of vector field f bar, that is f1, f2 and f3. Now we have to find out this determinant I cap into minor of I cap, that is del f3 by del y minus del by del z f2, then after minus j cap, minor of j cap, leaving second column on first row, that will be del by del x of f3 minus del by del z of f1, finally plus k cap, minor of k cap, leaving first row and third column, del by del x of f2 minus del by del y of f1. You can see that the curl f bar is a vector quantity. A vector field f bar is said to be rotational if curl f bar is 0. It means if curl f bar is 0, then the given vector field is called a rotational. If f bar is nebula phi, then what will be curl f bar? Curl f bar is nebula cross f bar, and here we are taking f bar equals to nebula phi. So replace f bar by nebula phi. Now if you will find out the cross product of nebula and nebula phi, the result will be 0, right? So curl f bar, if curl f bar is 0, then we have one important result, f bar equals to nebula phi. So if curl f bar is 0, then we will be having f bar equals to nebula phi, and from this relation we will be in a position to find out the scalar potential function phi, and how we will see with the help of one example. A rotational and conservative, both are synonyms. Now we will take some examples. Example number 1, we have to find out the divergence and curl of v equals to x y z into square bracket x comma y comma z. So solution, v equals to x y z, and this is nothing but the vector xi plus yj plus zk. Now multiply this by x y z, so that will be the result x square yz I plus xy square z j cap plus xyz square k cap. Now we have to find out this divergence. So divergence of v, that is the dot product of nebula and v. So as per definition, del by del x, x component of v plus del by del y, y component of v plus del by del z, z component of v. The partial derivative of this function with respect to x, so yz will be constant and derivative of x square is 2x Now partial derivative of xy square z with respect to y, xz will be constant and derivative of y square is 2y, and partial derivative of xy z square with respect to z, xy is constant and derivative of z square is 2z. And if you will find the total, the result is 6xyz. So this is the divergence of given vector field V. Now we have to find out its curl. How to find curl? Curl, that is curl V, that is equals to nebula cross V. Nebula cross V, that is determinant of ijk del by del x del by del y del by del z x, y and z component of the vector field V. Now we have to find out this determinant, that is I cap into minor of I cap, that is this one. So del by del y of xyz square minus del by del z of xy square z minus j cap into minor of j cap, that is del by del x of xyz square minus del by del z of x square yz plus k cap into minor of k cap, that is del by del x of xy square z minus del by del y of x square yz. Now partial derivative of xyz square with respect to y, the result is xz square. Partial derivative of xy square z with respect to z, the result is xy square. Partial derivative of xyz square with respect to x, the result is yz square. Partial derivative of x square yz with respect to z, the result is x square y. Partial derivative of xy square with respect to x, the result is y square z, because the derivative of x is 1 and y square z is constant. Now partial derivative of x square yz with respect to y, x square z is constant and derivative of y is 1, so the result is x square z. So this is the required curl of given vector field V. Now we will move on to second example, that is example number 2. We have to find out the values of constant ABC such that the given vector field V, that is this one, is irrotational. It means we have given that this vector field is irrotational, and subjected to this condition we have to find out the values of ABC. Since V is irrotational, it means its curl will be zero vector. So nebula cross V, that will be determinant of ijk del by del x del by del y del by del z x, y and z component of given vector field V, and that is equal to zero vector. Now we have to find out this determinant, that is I cap del by del y of 4x plus cy plus 2z minus del by del z of dx minus cy minus z minus j cap del by del x of 4x plus cy plus 2z minus del by del z of x plus 2y plus az plus k cap del by del x of dx minus cy minus z minus del by del y of x plus 2y plus az, that is equal to zero vector. Now partial derivative of this function with respect to y, result is c. Partial derivative of this function with respect to z, the result is 1, and over here we have minus sign, so minus minus plus. Partial derivative of this function with respect to x, the result is 4. Partial derivative of this function, the result with respect to z, the result is a. Partial derivative of this function with respect to x, the result is b, and partial derivative of this function with respect to y, the result is 2. Now that is written over here, c plus 1 I cap minus 4 minus a j cap plus b minus 2 k cap, that is equals to 0 vector. Now comparing both sides, we have c plus 1 equals to 0, so value of c is minus 1, minus of 4 minus a equals to 0, so value of a is 4, and finally b minus 2 equals to 0, so value of b equals to 2. So these are the required value of ABC for the given vector field to be irrotational. Now moving on to example number 3, that is we have to show that the given vector field f bar, that is this one, is both solenoidal and irrotational. For the given vector field to be solenoidal, we have to find out its divergence, and that will be 0, and for irrotational we have to find out its curl, and that will be 0. So here first of all we will find out its divergence. So divergence is nebula dot f bar, that is equals to del by, as per definition, del by del x, x component, plus del by del y component of f bar, plus del by del z, z component of f bar. Now partial derivative of this function with respect to x, the result is minus 2. Remaining for these three functions are functions of y, z. So its derivative with respect to x will 0. Now partial derivative of this function with respect to y, the result is 2x. Now partial derivative of this function with respect to z, the result is minus 2x plus 2. 2x will cancel out, minus 2 plus 2 will cancel out, the result is 0. Hence we can say that the given vector field is solenoidal. Now for the given vector field to be rotational, we have to find out its curl, and curl is nebula cross f bar, that is equals to determinant ijk del by del x del by del y del by del z. This is the x component of given vector field, this is y component, and this is z component. Now what we have to do, we have to find out this determinant, and that is written over here, right? I cap, and this is the minor of I cap minus j cap, this is the minor of j cap plus k cap, and finally this is the minor of k cap. Now we have to find out the partial derivative of this function with respect to y. Partial derivative of this function with respect to y. We can see partial derivative of 3xy with respect to y, the result is 3x. Then after 2xz and 2z, these are functions of xz, so its derivative will be 0. Now partial derivative of these functions with respect to z, over here it will be 3x, and for 2xy it will be 0, so the result is minus 3x. Similarly, partial derivative of this function with respect to x, the result is 3y, and for here it is minus 2z, for 2z it is 0, for y square it is 0, for z square it is minus 2z, so minus minus plus 2z, for 3yz it is 3y, and over here it is minus sign, so it will become minus 3y, and for minus 2x it will be 0. Similarly, you can find out the partial derivative of this function with respect to x and partial derivative of this function with respect to y, and the result is 3z plus 2y minus 2y minus 3z. Over here 3x and 3x will cancel out, 3y will cancel out, 2z and 2z will cancel out, 3z and 3z will cancel out, 2y and 2y will cancel out. So overall the result is 0 vector. Hence we can say that the given vector field f bar is rotational. Now we will move on to the last example, that is example number 4. So here we have to prove that this given vector field f bar is conservative. Conservative means rotational. So for the given vector field to be rotational, what we have to do? We have to find out its curl, and curl will be 0. And then after we have to find out its scalar potential function. If the given vector field is conservative, then we have one important result, that is f bar equals to nebula phi, and from that we will be in a position to find out the scalar potential function phi. How? We will see. So first of all we will show that the curl of given vector field with the field will be 0. Now nebula cross f bar, that is equals to determinant of ijk del by del x del by del y del by del z. This is the x component, this is the y component, and this is the z component of given vector field. Now we have to find out this determinant I cap into minor of I cap, that will be del by del y of z square minus xy minus del by del z of y square minus zx minus j cap, this will be the minor of j cap. So leaving second column and first row, that will be del by del x of z square minus xy minus del by del z of x square minus yz, and finally plus k cap del by del x of y square minus zx minus del by del y of x square minus yz. Now we have to find out the partial derivatives, right? So partial derivative of z square with respect to y, the result is 0, and partial derivative of xy with respect to y, the result is minus x. The result is minus x. See, this is the result minus x. Then after the partial derivative of y square with respect to z, the result is 0, and minus zx with respect to z, the result is minus x, and minus minus plus x. So the result is plus x. So minus x plus x, that will be cancelled out 0. Similarly, you can find out the partial derivatives of remaining functions. The result will be minus y plus y and minus z plus z. So these will be cancelled out. Minus y plus y, minus z plus z, and minus x plus x will be cancelled out. So overall result is 0 vector. So we can say that the curl is 0 for a given vector field, so the given vector field is conservative or irrotational. If the given vector field is conservative or irrotational, then we have one important result, that is f bar equals to nebula phi. And f bar is given to us, that is this vector field, and nebula phi, that is gradient phi, and that is I cap del phi by del x plus j cap del phi by del y plus k cap del phi by del z. Now comparing both sides, the coefficient of I, j and k, we have del phi by del x, that is equals to x square minus yz, del phi by del y, that is y square minus zx, and del phi by del z, that is z square minus xy. With the help of these three equations, we will be in a position to find out the scalar potential function phi. So first of all, we will integrate the equation 1 with respect to x. If you will integrate left hand side with respect to x, it will become 5. And integration of x square, the result is x cubed by 3, and yz will be constant. So yz will be as it is, and consider 1 over here. So integration of 1 with respect to x, the result is x. So it will become minus xyz. And plus, we have to write down function of yz, because yz is constant over here. You can see the result I have written over here. See, it is phi equals to x cubed by 3 minus xyz plus function of yz. Now similarly, what we have to do, we have to integrate the equation second. So in the left, integrate equation second with respect to y. So in the left hand side, we will be having 5. Integration of y square, the result is y cubed by 3, and integration of zx with respect to y, the result is xyz, and plus function of zx. Similarly, for equation 3, the result will be phi equals to z cubed by 3 minus xyz plus function of xy, and that is written over here, right? You can see, right? Okay. Now we have to write down 5. So phi, that will be, we have to write down all the terms, right? But we have to write down the repeating terms only once. That is the scalar potential function phi, that is equals to x cubed by 3 plus y cubed by 3 plus z cubed by 3. Here xyz is repeating 3 times, but we are going to write it only once, that is minus xyz, and these are constant values, so these are constant functions, so repeating all these by the constant, that is c. So the required scalar potential function phi is x cubed by 3 plus y cubed by 3 plus z cubed by 3 minus xyz plus c. Thank you for watching this video.